right, we're going to go over that worksheet we've been working on, and then we are going to get a new one for learning some factor label method. So let's go ahead. Did we do this problem already? Number 7? Good work. So the
We're done with the whole thing.
We're done with the whole backside.
Okay, and we checked all of our answers.
Yeah. Well,
Yeah.
everything else.
Okay, I'm gonna scroll, make sure we got that one we did.
Yeah, because we watched Mark Romer.
Oh yeah, because we got ahead. All right, go ahead and turn that worksheet in with your name and class period on it over in the turn and bin. So you're the period 8 chem on the left side there. There's one that says period 8. Yep, but Monday. Yep, of course. All right, and I'm going to hand you this worksheet.
Okay, just here, back over there. Send communication, send communication. And then it's information, that's tailored to the group. To get access, so to the very best. Okay, and then this would be one. Then here's just a so like the fine. Yep. Yeah, and that's so okay. Okay, yeah. Thank you.
All right, here is the first factor label method was field. On the top, the ones in yellow are versions that I just kind of expect you to have as prior knowledge here. So if you know, just check that out. I think the ones kids struggle with, for the most part, would probably be the 2.54 centimeters in an inch, and the 1 mile is 5,280 feet. So just, I do tend to expect that you know that from prior classes. Oh. So this first one, we're going to convert from 26 centimeters to meters. So the way we're going to do that is we are going to do what's called conversion factor method. So when we are using the conversion factor method, we always start by writing our given quantity first. I was hoping it would just like work. All right, so we're going to write our conversion factor after our conversion. Try to figure out how I can write on my screen while I'm recording, while I'm projecting, and it's not really working very well. Alright, I guess people watching might just have to...
Turn on the pen.
Just turn on the pen. Oh, there you go, thank you. Alright, I wonder if it'll work with my stylus now. Nope, I have to write it. Oh, okay, it's gonna look really ugly, but I'll try it. Cannot... Oh. My stylus just doesn't work. Okay, so you start by writing what's called your given quantity, and our given quantity is whatever we start with. So for this problem, we're starting with 26 centimeters, and we're going to take 26 centimeters and convert it over to meters. So remember, the conversion, you have to remember, is that there are 100 centimeters in 1 meter. Now, since we know that we're going to do what's called making a factor out of it, we call this an equality statement. And what we can do is, because the 100 centimeters is actually equal to the 1 meter, like 10 is equal to 10, if we're to put that into a factor form, it would be like 10 over 10, right? When we put that into a factor form, we then can manipulate this centimeters and get it to meters by keeping the quantity the same, but changing our unit. Because what is this really? 10 over 10 is equal to what?
1.
1, exactly. So if I were to write 1 meter over 100 centimeters, it's actually equal to 1. So if I were to multiply this by a factor like that, I'm not changing the value of it, because it's equal to 1. But what we're going to do is we're going to do it in such a way that this centimeters changes and we end up with meters. So in math class, if you were to have x times 1 over x, what happens to those x's? They're going to cancel out, because technically this is over 1, right? And what that's actually equal to is x times 1 over x times 1. The x's cross off, and that's just 1, so that's just equal to 1. Oh, I have a little Orby there. Okay, let's pass that. So that is equal to 1. So what we're going to do is intentionally make that happen here for us. We are going to, I don't know how to make it not be a pen anymore, or how to erase though. Okay, so we're going to make this a conversion factor that the x's crosses off. So if we've got centimeters on top, what do you think we want on bottom? Centimeters. So we're going to write 100 centimeters on bottom, and that is equal to 1 meter. So because I have centimeters on top and centimeters on bottom, it's going to cross off. And then what we're going to do is, remember, just like x times x divided by 1 times x, we're going to do 26 times 1. And then this is technically over 1. So then 1 times 100 on the denominator. So I'm going to take 26 and I'm going to divide it by 100. So what I'm going to get then is 0.26, and my unit is meters. Circular box, your final answer. Thought I'd have an eraser. Just erase it all. Okay. So again, I'm going to write it clearer here for you. So we start with our given quantity, 26 centimeters. We take it times the conversion factor of 1 meter over 100 centimeters. The centimeters cross off. I'm left in meters for a unit. I have to take 26 divided by 100. So my final answer is 0.26 meters. Circular box, your final answer.
Are you teaching this way? Because it's going to get harder. Or-
Yes, exactly. So I know this is something you can do in your head, and you could do the slide rule, but we actually use the same process for doing something called stoichiometry. So like the end goal of chemistry is to be able to predict a chemical reaction and know exactly what comes out of it. One of the things we'll be able to do is tell how much mass. So like if we were to explode something and hydrogen was released, we could be able to calculate exactly the volume of hydrogen put into the air to determine whether it's toxic or not. Like those are the kind of things that you can apply this to. Or if you're trying to make something, like how much do you need of it to complete the reaction so you don't have anything dangerous left behind. Like there's a lot of applications in the long term. But we start by doing something that we can do in our head, because at a first glance you should see, does this make sense? Yeah. When we're talking about hydrogen coming out of a reaction, you wouldn't be able to eyeball it like that. So we start with something that's easy. Good question. All right. Number 2, let's see if you can try it on this one. So what is our given quantity? 24 hours. And the relationship of hours to minutes that you already know is what?
60 minutes.
Exactly. So 1 hour is equal to 60 minutes. Now I think this is actually a really good just problem solving like skill as well. I've literally used it for like fuel to oil ratios when I just have like just a little bit of gas left and I want to use it all. And then I just know exactly how much oil to put in it. Because the ratio that they give you for the fuel to oil ratio you can use as a conversion factor. If you start with your volume of gas in gallons and they give you the ratio, you can spit out exactly how much you need. I've used it for baking. So say you only have so much of the recipe, you can calculate that too. There's a lot of applications too, daily. Make you a better problem solver. Alright, but we also can't forget sig fig. So if we take 24 in their calculators and take that times 60, if you want to do it in your head, you probably can do that as well. We're going to get 1440. But remember, sig figs tell us that I only have 2. The only thing that matters for sig figs is your given quantity. So my given quantity here is 24, so how many sig figs? 2, so I'm going to go 1, 2, look to the right, am I going to round up or stay? Stay, so 1.4 times 10, I move it 1, 2, 3 places to the third. My unit is minutes. Circular box, your final answer. Try number 3.
Might help out.
Hmm?
Do us to three.
Yep, go ahead. I'll jump in and try to help you with it too, but figured I'll give you some time to process first. I was going to show you that bag could work too, but I didn't want my confused, so I don't have an eraser, so I just rewind through it. Odds are you probably use this conversion factor, hopefully, that 1 kilometer is equal to 1 meter. So because I started with kilometers, it's the unit I want to put on bottom. So 1 kilometer, 1,000 meters. Kilometers cross off. You're just going to take 3.25 times 1,000. Now, anytime you're multiplying or dividing by base 10, if there's 3 zeros, that means I'm going to move the decimal out 3 places. So my number in standard notation would be 3,250 meters. Okay, but in scientific notation, with the correct number of sig figs, how many did I start with? 3, so I can only have 3. So 3.25 times 10 to the third meters. You getting it?
Yeah.
Sweet. Okay, go ahead. Watch your sig figs.
Does it need to be in scientific notation?
I'm going to do both. This being a smaller number, it's not such a big deal. But if it were over, say, 3 digits, do for sure. Like over 100 place, you listen to the thousands. But you're never going to be wrong for putting in scientific notation. As long as you do it right, I suppose. Right. So, probably see 60, but what happens here though? How many sig figs do I need? 3, so I need to go dot 0. My unit is inches. So 60.0 works. So does 6.00 times 10 to the first. Alright, I'm going to exit out of presentation mode so I can give us a few more slides to work with. I'd like 1 through 7 done by Monday for sure. What's that?
Click. Oh, it's for sig figs, you just match what you're doing at the beginning, right?
Yep, whatever you were given to start with. Oh, they're both 130 pounds. I was like, this is really throwing me. 130 pounds to newtons per 5, and 6 is 130 pounds to kilograms. And 7. 34 fluid ounces. 2 milliliters. Five was the last one I didn't do, right? Or did I do?
He's not do five.
I did not do 5. Correct. Thank you. It's probably really loud in the video. No, it's not on. Turn on pencil. There we go.
So there's 7. We do what's in the or like because we
So
have
44 is the sig figs, so 2. So you're asking?
it doesn't give us full 1 fluid ounces. Yeah, 1 fluid ounces.
It gives you 12 fluid ounces, so you use the same. You just actually have to like multiply or divide with that number based on where it's at.
You just have much steps.
So you have something over 12, and then you do that before you multiply it times 44.
Yeah, well, you can do multiplication and division in any order, so you could take that times the top and then divide by the bottom.
You said just 7.
Yep, if you want to move ahead, you can. The rest of the classes only got to this one.
Oh.
They are still behind you. When I'm gone one day, it is like a long time to get caught back up. It does. It takes a long time. Five, 7. So 5.78 times 10 to the second newtons is what I got for number 5. Should have 3 sig figs per decimal. Oh, this is actually 130. It's not 30. I need to change that. 130. So 130. Ah, shoot, I didn't change it. It's kilograms. Could distribute kilograms. Change that. Pound over 0.454 kilograms. So you'll take 130 times 0.454.
Sure. Are we going to do this in class, or is it going to be homework in the future?
We'll probably do the few in class which we'll probably get through most of it in class. We can try
You
to,
have to have like you put it on the top and then you have to have like one parenthesis and another one, right?
yep, you just do the same thing, just keep lining them up. And anything that's on top, you'll multiply by anything on the bottom, you'll divide by. Now we need to take 44 times 355 and divide it by 12. So we got 1.3 times 10 to the third.
Yep.
Perfect. Right.
For number 12,
Yes.
I skipped all.
Okay.